then, of course, we've got these two. So you got those four. So don't put little words next when adding, or so don't put any. That's all you can have. Are there any other suggestions for formulas that you want to put on your formula sheet?
What is there m times n for
Oh, that's an idea.
Normal.
That's an idea. Okay, cool. So that's all you can add on the formula sheet. Now, throughout the semester, you can start adding stuff to the formula sheet and just keep bringing the sheet. You could do a whole other sheet. You could bring a ton of sheets of stuff. You could put one letter on each sheet. I don't care, right? You ever had a class where you could only put it on a... I mean, that's what the hell? So I'm going to do like my joke is I'm going to make people do it on a grain of rice. So you have to learn how to do it, and then you can, what's that formula? That's bullshit. So put on as many sheets of paper as you want to, as long as you don't bother anybody else around you. Okay. Just to remind you guys, this test is only going to go up through 7-1, through the counting stuff. We didn't get further into 7 yet. We will. Ronald, right?
Yes, sir.
We can't put the names of the...
No. No. Because I'm mean.
Oh, man.
Evil.
Can I ask questions about the quiz?
Of course. Alright, so everybody got that? So this is your formula sheet there. I'll leave that there. This is all it can be. You can have the words formula sheet on there.
What cheat sheet? Anything?
Sure. Silly to call it that. But if you want to call it that, you can. I don't care.
I'll call it a helper.
Helper. I like it. Sort of like from Venture Brothers. Helper. Alright, guys. So you got a question from the quiz?
C and
So, this is 2 on the quiz. So everybody's was a little different. But everybody had something that looks something like this here. What do you got, Jeff? I believe I didn't get too weird, did I? No, okay. Right, everybody's 2 look like that, right? You agree with me? You must agree with me. The better at math you are, the more you're like, well, that's exactly the same as my number 2. Right? If you're not so good at math, you're going to say, no, that's different, Jeff. I didn't have any D's or M's. No, but I think most of you guys might see what I mean. That's the same problem you got. What do you do with, what if these weren't there? What if that was the only part of the problem?
you divide.
Yeah, some of you guys put 3. Or maybe even -3. When did 15 divided by 18 ever be 3? Right? So you guys are mixing up how exponents act with how numbers act. I like it. There is no 2 in that equation, or in that expression. There is no 2. There isn't a single 2 up there. I love the way some of you guys are looking at me. Jeff, you wrote it. No. What does that 2 represent? That's not a 2. That means that there are 2 D's. Right? So they're not going to act the same as regular numbers do because they aren't numbers. They're just keeping track of how many of these there are. So this is going to act the same way it always has. It can't suddenly change how it acts. So how do you do 15 over 18? Yeah, 3 goes into both. 5, 6. Now here's how I do the letters. You can use the properties. Obviously the properties are true. But I don't like to bring negatives in when I don't have to. How many D's cancel?
7.
How many D's cancel? 2. How many are left?
7.
Where?
11.
There. Done. 2 minus 9 is -7, right? Good. And then you would have to flip them down. Why not just put them where they would be in the first place? Does that make sense?
Why did the top one disappear?
They didn't, well, they did. D times D over D times D times D. Right? So there'll be 7 left on the bottom.
Okay.
So they disappeared the same reason that the 3 here disappeared. Right? 3 disappeared. Why? Because it canceled. Yeah. Same exact reason. And what about the M's? How many are left there? 12 on the top. Does that make sense? Because there's 14 up top. These 2 kill 2 of them, but there's still 12 of them left. Right? So medieval times, these guys won. Yay. Like Curtis laugh. What Game of Thrones section. Okay. So everybody's number 2 worked just like this.
I don't know what I was thinking.
Well, I mean, sometimes you get too many ideas all at once in the old head, and you try to apply the wrong one at the wrong time. I can understand that. And which, you said something else too?
Yeah. My number 2.
Oh, why did I do 1C? You asked about 2. Well,
Well,
a
I
lot of
asked
people
for
make
both.
Okay, so 2, yeah, there were 2 main types on that problem. I mean, some of you guys had one that looked like this. Something like that. And you had to write it in scientific notation. One of the biggest, bless you, one of the biggest mistakes was you put the negative power at the wrong time.
What?
Would this be a negative power or a positive power for the answer? Because this is a big number, right? You want to actually multiply by so many tens to make it bigger, bigger, bigger. If this was 0.000, now I want to divide by tens. Now it's got to be a negative power on the 10. So it's going to be, so where am I going to end up with the decimal? I got to move it how?
Between the 5 and the 7? No?
The 4 and the 5. You always want a single digit
4.
point, whatever. You're trying to suck all the tens out of this. And if you stop at 45, 4T5 has a 10 in it. Still suck that 10 out. So you got 3, 6, 8. I like it. 4.57 times 10 to the positive 8th, because it was a big number. Some of you guys had this on, this is number 2. Yeah. Some of you guys had this here, 0.000000071, whatever. Same idea, it's just going to be a negative power. But the exact same reasoning to figure out what the number is going to be.
I thought you told us, like,
Would it be 7.1?
Yeah, it will be eventually. What's up?
I thought you told us that you just had to put, like, you had to have, like, one number on the other side. Or something.
One number here.
Oh.
Yes. Because again, 45 has a 10 in it. Do you see what I mean? 45. What's that 4 mean? 4 what's? Tens. Okay, it's got some tens in it.
Mm-hmm.
The whole idea of scientific notation is to take all the tens and put them on the side. So if you make the decimal stop here, you haven't taken that last 10 out yet.
Okay.
I like it. So that's why this has always got to be a single digit dot whatever times 10 to the whatever. That's the form it's got to be in. So here it's going to be eventually get there. So how many times you got? 2, 4, 6, 8, 9, 7.1 times 10 to the negative 9 because it was a small number. Yes, sir.
For that, I remember you telling us it goes to 1 through 9, right? No, 1 through 9.
Yeah. This number here, 1 through 9.
Only 1 through 9.
Exactly. Right. If it was a 0, the decimal went too far. If it's a 10, the decimal didn't go back far enough. Does that make sense? I mean, it's, yeah.
So if it starts with a 0, and then the second on the right, it'll be a negative all the time.
Yeah. If the number you're dealing with is less than 1, it'll be negative power. If the number you're dealing with is bigger than 10.
I had it.
It's gonna be positive power.
You go right, it'll be positive.
Yeah, see, I hate it, not just because I suck at direction. So when I'm driving and somebody's giving me directions, I have to drive like this because that's left. I've gotten better. I've got too much other shit in my head. So you guys can, that's fine. You can make fun of me, whatever. I don't care. I know a lot of other shit. I just don't know this. So I hated that. Plus, if you go from this way back to this way, it's the other direction. So I'm like, shit. So it makes so much more sense if it's a small number. How do you make a number small? You divide it by stuff, right? So I actually want to divide by 10. Where do these 10s want to be? So negative power, so they would want to be down, right? So you are taking 7.1 and then dividing it by 9/10. That's why it gets so damn small. That's why a negative power goes with a small number. It only makes sense. It makes a lot more sense than left and right bullshit, right? Okay, cool. Nothing against left and right.
Can you go back to B, to number 1B? Let it be.
Oh, so that one was sort of like a part of the one we did, number 2. Right, so it's like this part here. Everybody's number 1B was something like, something like G to the 7th over G to the 19th. So again, you could do this. You could say G to the 7 minus 19, because what's the rule? You subtract powers. 7 minus 19 is?
You get -12.
Negative 12. But then don't stop there. You can't have a negative power at the end. You got to go one more step.
1 over.
1 over. Me, personally, I would just do this. Screw all that shit. 7 of them cancel. 12 are left on the bottom. But there's nothing wrong with doing this. This is beautiful. This is perfect. This is lovely. There's just a bit of a quicker way to look at it, but it doesn't matter if you look at it the quickest way. It matters if you look at it the way that makes sense to you, right?
Always.
Always. Find a way that makes sense. Yes? So that was the one that's going backwards here. So if I gave you this, you would move the decimal 8 places that way. 1, 2, and then 6 zeros. If I gave you this, you would move the decimal 9 places back. Here's a cool thing. If it's a negative power, is you have to move it once around that 1 digit, so there's always going to be 1 less zeros in front. So there would be 8 zeros in front of this thing. So number 3 is just the opposite of number 2. Yeah.
For number 4, like you can remember commutative of dot.
Oh, I didn't take points off though, right?
Wait,
No, but like what do you mean?
So it's commutative of addition or commutative of
Oh,
multiplication.
somebody write it down.
Huh?
Community of like addition.
Yes, cool.
Oh.
I didn't take points off because I really just was interested in you knowing the commutative or associative.
Okay.
The of addition or of multiplication is sort of, a little bit extra, a little icing on the cake.
I forgot the commutative. I put multiplication.
I like a few people were trying to describe to me what was happening. Thankfully, I don't think anybody treated it like it was a problem to solve, which is good. Okay. I think we talked about every one of them. Okay. So I just remind you, you can make corrections. They are due tomorrow. And if you turn anything in late, you'll still get points for it, just less points than you would have originally. So you can always turn in quiz corrections text late. Right? But if you want full credit, as much points as you could possibly get back would be turned in tomorrow. What's my reasoning for that? Well, because the test is going to be on this stuff. If you do the corrections, hopefully you understand it better.
Hopefully.
Hopefully. Okay. Have you guys tried out? Now, you don't have to, please, dear God, don't turn in the practice test to me. You can show it to me if you got a question or something. I've got the answer key. I'm going to give it to you a little bit. You don't have to do this at all. The best thing you can do for yourself is make sure that you do the homework.
It's great practice.
Yeah, but this is good practice, right? I've got the answer key. The worst thing you could do is, if you get the answer key, just stare at it and go, yeah, I would have done that.
Me.
Right?
It doesn't work.
Trust me, you gotta force yourself not to do that, because you're gonna build up this false confidence. If you don't have it written out, you have nothing to agree with. You have to do it yourself. It's no good. Does that make sense? The very first time I taught, I made a practice test, and then I gave out the answer key, and then people got upset at me. They're like, 2 things. They were like, well, I studied that practice test like crazy, and I'm like, well, then you knew those problems. You didn't understand the idea. I'm not going to give you those same problems, right? And secondly, somebody else is just looking at there, and I thought I knew everything. I was looking at your answer key, and I'm like, I wouldn't, so that's why I say that now. It's like, use this correctly.
Okay, I get it. Move on.
But see, when you, it's easier to agree with something that's already done
Yeah, true.
than to do it yourself. Yeah, I understand that. All right, so you guys want, if you have a specific question, let me know. If you just want to work on quiz corrections, do it. If you want to work on homework, do it. Do something productive. You have me here.
Use me.
If there's problems in the homework, you got a question, just shout it out. If you want me to come to your desk for a specific thing, let me know. You can start trying the practice test out before I give out the answer key. Whatever you guys want to do.
So we could correct these, right?
Yeah, of course. Correct both the quizzes. Oh, cool. Yep.
The homework 7.1 is that for tomorrow?
Yes.
Yeah.
7-1 is due tomorrow. But 7-1. So this test goes up through 7-1. The rest of 7 we'll do after this test. But tomorrow you got to do up through homework 7-1. If you haven't tried it yet, it's not that terrible. There's not a ton of problems.
I thought you said yesterday it wasn't due till next week.
Yeah.
What do you mean? No.
Yesterday you said one's not due till next week.
Yeah. Next.
Oh, next test. Yeah.
No, the rest of 7 won't be due till next test. We went over 7-1 yesterday. We went over 7-1 yesterday. So of course that homework is due tomorrow. It's going to be on the test. It's there's a problem like number 7. Aw, misheard me.
So it's
How do you want to do more work?
everything from here up.
Yeah.
Okay, cool. I get confused on because there's no like exact due dates for the homework, so I'm like, or like when it's assigned, so I'm like, wait, which one?
It's always, at the worst, the day of the test. So you do sort of have a due date. Hopefully you turn it in before then. Oh, so this doesn't make sense that way. Okay, because it would be 6 over x. Doesn't tell me how you got 6. So for one thing, see how I put equals? So then you can cross multiply and solve for x. So this doesn't make sense. I know what you mean, but you need to write it right so that later you don't make some mistake with it. Yeah. So it is solving an equation. What does needed without need? What does that mean? You had to rewrite it in expanded form. 5 times. Times another 11 pieces. So then how many pieces are there in a row? You have 5 pieces in a row here, times another 11 pieces. Yeah. And that's why you do it, because the next one is you're just keeping track of how many beads you got in a row. So if you attach another string of 11, of course you got 16. So when you multiply like bases, you add it. And let it be easy. The reason it's easy is it's just keeping track of how many you have. Right.
So this one.
So that's the opposite.
I think this one, right?
You did that one right. You just want one more step. The last couple points because you never stop at a negative power. That just means flip. A negative power just means flip.
So
1 over. X is And see how from the very beginning, can you see how there would be 5 x's left on the bottom? Because that's where most of them were in the first place. So this is correct, it's just one more step, going over x. So when you're multiplying, you're collecting. When you're dividing, you're losing.
I should have saw that anyway. I don't know what all answer by that.
I know, it was weird to me why it didn't. Yeah. Oh, it's weird 1.4. But it can't be. You see what I mean? That's like 2 over 3. It can't be 1.4.
But does it show
But do you understand what I'm saying? The top is smaller than the bottom. How can the result be 1.6? Does that make sense? Just by itself. So just plug it in the calculator and see what happens. You might have done 3.8 divided by 2.2. But it's supposed to be 2.2 divided by 3.8. Yeah. Sure. Yeah, you gotta start from the back and go to right after the 1. So there should be 8. Exactly. Yeah.
I'm still a little confused on this one. So if it, I like wrote it out, so I don't.
Well, it was weird. Where is the decimal? I mean, that's the best I could tell us where the decimal was. And that's the wrong place.
Did I put too many zeros or?
But not enough.
Decimals? Okay.
Well, yes, on both counts.
Okay.
The decimal should be back 1, so there should be 1 more 0 in between.
So there
You gotta go back 5. So you gotta go back 1 so not the 4, and then there should be 4 zeros, because that's, you still gotta go back 4. Yeah.
So if I.
Yeah, but
Zero and then a decimal, 2 or 0.
And then just 1 0. There's only ever 1 0 in front of it.
So now we're writing it like this. This is
Yes.
like how that is.
Yeah, these are the reverse of each other. So that should end up looking like that to begin with. It's a small number, it should be negative power, but how many times can you do 0? 3 zeros?
So I start from right here.
No. Where's the decimal?
Okay, I start from right here.
Yeah, and then you move it till it's there.
Okay. 4.
Good.
And then, okay,
So negative.
so then I put negative 5 at first, so I kind of get the little.
Jeff, you know.
So you start counting the decimal